Yes, members, welcome back to our channel, Math in Motion. We are back again. Welcome to this edition. Today, we're going to talk about descriptive multivariate statistics. Remember, members, we have univariate statistics where we're talking about one variable against a dependent variable. But right now, we're going to be talking about multivariate, means uh, a number of variables. Take an example. You may be talking about you want to fit a model where you want to talk about the what determines your CGPA. CGPA is determined by a lot of things. You may try to talk about the amount of lecture hours attended to class, number of lecture hours attended to class, type of food you consume, or your age, or even a lot of things. Now, want to put into consideration all those other factors that affect our dependent variable, which is CGPA. Right now, today, we want to let us talk about the measure of central tendency. First of all, we need to talk about the measure of central tendencies. For here now, we mean measure of central tendencies. We're going to be meaning the mean. Shall be certain find sample mean. Now, if we had one variable, remember our mean for one variable, we say that x bar is the same as having 1 over n summation of xi. We just sum the number of variables we have and then divide by their number. Yes, that is the sample mean. But now we have a vector of variables. We have very many variables. We have one variable x1, x2, x3. Therefore, shall we need to find out the sample mean vector. The sample mean vector. This will apply if you have a number of variables. Take an example. We may be having, remember, we may have like one to determine what determines your CGPA. We may have variable 1, variable 2, up to variable XP. Yes, there are very many variables. And then we have the different individuals we are measuring. We have individual 1, 2, 3, up to n, individual n. Now we want to find now the mean of each variable. Like say this is age. Now find the mean age. Now say this is, we say max squared. This is also going to be the mean mark up to when you have different variables. Therefore, in order for us to find the sample mean vector, we just need to add the variables and like the variable age and then divide by the number of individuals we are testing on. Therefore, our sample mean vector is going to be the same as having individual means for each variable. We shall just have a vector that our sample mean vector is going to be just having the mean of x1, the mean of x2, up to when you have the mean of xp, because you have p variables. I think by that we shall just need to have an example, but I want to do one example which contains everything. This is the measure of central tendency. Now, members, allow me to take you through also the measure of dispersion. Like how do we see that how is that these variables dispersed from the other? How are they spread out away from the mean? Now, members, let us put off this again. We now go in for the second measure, the measure of dispersion measure of dispersion. We have a measure of dispersion. Our second is going to be measure of dispersion. For measure of dispersion, now we're talking about now variation. Like how are these variables far apart from their means? The measure of variations. Remember, when you have a single commodity, when you have a single variable, our variance of x1 is just always 1 over n minus 1 summation of that xi minus its mean squared. I think we call that is the formula we used to use when we have only one variable. This is for one variable. We want to measure the variation between that variable. That's the formula we use. Now, when we have two variables, and then now we can find out the covariance. We are seeing how these two variables vary with each other. Therefore, our covariance, shall be saying that our covariance of x1, x2, or x1, x2. Now let us use now general terms xj, xk like this. We have two different variables, xk and xj, shall have the same as having 1 over n minus 1. N is the number of individuals that we are testing. then time into summation, yes, of now xj minus xj bar times xk, individual values of xk minus xk bar, and then this will enable to give us the covariance of between two variables. And lastly, we shall now find the sample covariance vector. Now we shall find the sample covariance vector. Which is the same as having, yes. Now remember we said we have very many variables. We shall have the variance of x11 here. Just talking about x11. We shall have now variance of x1, I think covariance of x1, x2, up to when we reach covariance of now x1, xp. Likewise, we have now here covariance of x1, of x2, x1. Now we shall have variance of x2 like that. And then here we shall have likewise, we have the covariance now of x2, xp. Then we shall also move down up to when we get the covariance. Now we shall have here xn and then xp. Sorry, we shall have xn, xps. Then we shall have again covariance of x2, xp. This is x1, x1, xp, up to when we have now the variance of xp, p. Something like this. This is going to be our matrix. And in a short form, I can write it as like this. Remember, variance is its symbol is S. I write it as S like this. Then shall have something like, you shall have S11, S, 12, S13, up to S1P like that. Then you shall have S21, S22, then S23, up to when you have S3P. Then you shall have again S. This is going to be N1, yes. Now S, this is going to be, this is SP1, yes. This is going to be SP2, SP3, and that way we have SPP. This is a simpler format of the sample covariance matrix. We said we shall find S12 using this formula, and find S11 using upper formula. I think members we shall be able to appreciate more when you do some examples, but just appreciate these formulas we are going to use while finding the measures of dispersion, which is covariance and the variance respectively. Lastly, we shall need to talk about the correlation, measure of correlation, which is the sample correlation. Yes, lastly, we shall need to talk about the correlation. The last, I'm saying at last we shall need to talk about our last variable is going to be the sample correlation. Our last measure shall be same measures of correlation. This is going to be our last measure. And the measure of correlation is just simple. We know that if you have a simple correlation r, small r, it's going to be the same as having, yes, the covariance between xj and xk divided by the standard deviation, sample standard deviation of xj times sample standard deviation of xk. That's simple like that, which is the same as having covariance is going to be xjk, sjk out of square root of now sjj times square root of skk. That's simple like that. And then now shall also form a sample correlation vector, which is composed of the vectors of the correlation. Remember, this is the form of the correlation we're going to be using. Yes, we shall have the covariance we've got in this previous thing from seeing sjk divided by this, now the square root of the variance of either one, if it was x1, variance of x1, variance of x2, like that. And lastly, we shall need to now to have a sample correlation matrix, which is got by R. The R is going to be like this in this format. The area of the major diagonal. Remember, here I have x1, x2, up to xp. The correlation between 1 and 1 is 1. X1 and x1 is 1. Likewise, for 2, up to when we have xp and p is going to be 1. Like that. The major diagonal is going to be composed of 1s. And then here we shall have area of 1, 2, up to when I have area p. Then you have area 2, 1, up to when you have area 2p. And then I shall also go for area P1, area P2, up to when you have the 1 this side, like that. I think with that, you can easily appreciate when you have an example. And the last formula you can also apply here on the sample correlation. R equals to the D inverse times S times D inverse. Now for this one, to recall it properly, this S matrix is our sample covariance matrix, which you have got in the previous example. If you have the sample covariance matrix, you can easily get the R matrix, which is a sample correlation matrix, by first getting the D. This D is the diagonal. The D matrix is the diagonal of the S matrix, but containing diagonal elements as the square root of SJJ. Like, we just need to get this the S matrix, which is a sample. Yes, let us continue with an example. I think that given that we have our example of a question, we have a table like this. We have x1, so you have here we have our n. We have x1, x2, and x3. We have that divided into, we have 1, 2, 3, 4, and 5, like this. Yes, from there, then you have our x1 it has values 20, 16, 20, 16, 15, 21, and then 19. 21 and then 19, yes. Then our x2 is contain 687, 95, and then lastly our x3 has 20, 34, and then a 6. I want us to find the question wants us to find, first of all, we have to find the sample mean vector. Second, we have to find the sample covariance vector, sample mean vector, yes. Sample covariance matrix. And then lastly, we need to find the sample correlation matrix. Members, let us begin by finding the sample mean vector. We say the sample mean vector is just composed a vector of means. Sample mean vector x bar equals to, we just need to get out the means of these different variables, x1, x1, x3. What is the mean of x1? The mean of x1 we get it by adding 20 plus 16 plus 15 plus 21 plus 19 divided by 5. If you add and divide, you shall have 18.2 as your answer. Yes. Also, to get the mean of this x2, you shall need to have 66 plus 8 plus 7 plus 9 plus 5. If you add and divide by 5, you will get your answer as 7. And then likewise, if you add 2 plus 0 plus 3 plus 4 plus 6, you have divide by 5, you will get your answer as 3. Therefore, members, this is our sample mean vector. As easy as that. Now let us go ahead and find out the sample covariance matrix. We said sample covariance matrix. We use the formulas. Yes, I think I have two of the questions. You shall be able to answer them. We are answering now question 2. Sample covariance matrix. Now, for sample covariance matrix, what do we do? Remember, we have our formulas. We have said that variance of x1 equals to 1 over n minus 1 summation of xi minus x bar squared. And then you have our covariance of x1, x2, or xi, xj, xk, the same as having 1 over n minus 1 summation of xj minus xj bar times xk minus xk bar, like that. Now, what we need to know that we need to have something like our sjk equals to variance of s11, s2, s12, s s13, s21, s22, and then s23, s31, s32, s33. This is what we need to get now, right now. Now, members, since we need to get that, now what are we going to do first? Let us first make a simple table, have our values we're going to compute, and then from there we shall be able to find each and everything we want to find from that thing. Yes, members. Now let's have some table, some kind of simple table like this. Let's have x1 minus x1 bar. We have x2 minus x2 bar. Then you have x3 minus x3 bar. This will make our life easier and simple so as to find those things we want to find. Yes, members. Let's go ahead. Now x1. What is our x1? X1 is 20. Shall now need to have 20 minus 18.2. Yes, and then I think we have the value here. What is 20 minus 18.2? Shall have 1.8. What is 16 minus 18.2? Shall have negative 2.2. I think I've calculated as well. We went together. Then shall have 15 minus 18.2. Shall have negative 3.2. Are we together? Yes. Then we have that thing. What else do we need? We have 21 minus 18.2 shall have 2.8. And likewise, we have 19 minus 18.2 where we have 0.8 as our answer. Remember, are we together on that point? I'm saying x1 minus x bar. This is x1, this is x bar. Also, let's get x2 minus x bar. X2 minus x bar is what? 6 minus 7 is negative 1. 8 minus 7 is positive 1. Likewise, if you have 7 minus 7 is 0. 9 minus 7 is 2. And then 5 minus 7 is negative 2. Like that. Likewise, let us find now x3 minus x3 bar. We have 2 minus 3 is negative 1. Have 0 minus 3 is negative 3. Then have 3 minus 3 is 0. And then what else do we have? We have 4 minus 3, which is negative 1. Sorry, 4 minus 3 is positive 1. And then 6 minus 3 is 3. Now, after us having that simple table, I think we can put off this and then we calculate our values with ease. Yes. Now, for us to find now, remember we need S11, S22, and then S33. S11, S22, S33, we get using this formula, the upper formula here, which is the same as having, remember how our n is 5, shall have 1 out of 5 minus 1, which is 4, now into x1 minus, this is, for 1 shall have now use this one, 1.8 squared plus squared plus squared plus squared plus squared. Yes, shall have, members, let us do it with ease. Shall have 1.8 squared plus negative squared is going to be positive 2.2 squared plus 3.2 squared plus, and then lastly 2.8 squared, and then last thing is going to be 0.8 squared, and then our answer is going to be 6.7. Likewise, like that, just easy. Just get and then get that answer with ease. Also, to get S22, we just come on S22 here. We have square and then divide by 4. Negative 1 squared is 1. 1 plus 1 is going to be 1 plus 1 is 2. 2 plus 0, 2 plus 0 is 2. 2 plus 4 is 6. 6 plus 4 is 10. Then 10 divided by 4 is going to be 10 divided by 4 is going to be 2.5. Yes, also here we have negative 1 squared is 1. Plus negative 3 squared is 9. Plus 1 is 10. 10 plus 1 is 11. 11 plus 9 is 20. 20 divided by 4 is 5. Our S22 is 5. Just like that. Now our task now is finding now covariance. We need to find out S12. S12 is the same as having S21. Yes. Then also need to find S23. So S13 and then S23. If I'm able to have these three matrices, therefore we shall be done with our work of finding the sample covariance matrix. Now, if we begin with X1 covariance of A1, 2, let us begin with 1, 2. 1 and 2. Just use this formula. 1 over n, which is 1 over n is 1 out of 4 into, yes? But together, now we need to have now this times this times this. We shall have now, this one times this one shall have negative 1.8 plus this times this minus 2.2. This times this is 0. And then this times this is plus 2 into 2.8. And then this times this is minus 2 into 0.8. And our answer is going to be it's going to be very easy, because it's going to be 0. If you add this and you have 0, divide by 4 is 0. Now we have now 1, 3. 1 and 3. What is it? 1 out of 4 into. This one times negative 1.8. This and this is going to be plus 3 into 2.2. And then this and this is going to be 0. Then this and this is going to be plus 2.8. And then this and this is going to be plus 3 into 0.8. Now, if you add and divide by 4, you have negative 1 over 5. No. Here it is now 1 and 3 shall have 2.5 as our answer. And likewise here, I just need to have 1 over 4 into now, what is it? It is now 2 and 3. 2 and 3. It's going to be a 1 here. So this one is going to be minus 3. This is going to be 0. This is going to be 2. Then this is going to be negative 6. Something like that. Then mass is going to be negative 1.5 as the answer here. I think, members, with this everything now is done. Now our task is now just formulating our matrix, our matrix, and then our is going to be the format of with ease. I want to be able to write our matrix as that SJK is going to be the same as having remember here we said our S11 is going to be 6.7. Yes. What's going to be now? This is 6.7. Then it's going to be 2.5. And then this is going to be 5. Something like this with ease. Now we begin. S12, the same as S21, is going to be 0. Have a 0 here and then have a 0 here. Then S13 is going to be 2.5. I have a 2.5 here. 1 3 the same as having 3 1, 2.5. And then lastly, S23 is going to be negative 1.5, negative 1.5, and then you have 2 3 the same as having 2 3, then 3 2 have negative 1.5. And I'm done with my sample covariance matrix like that. Yes, members, I think we can go ahead and we see how we can finish up now our question with the last part of it. Our last part of it was telling us to find now the our last part of it was telling us to find the sample correlation matrix. Now, our last part is saying that you find the sample correlation matrix. How do you find some correlation matrix? We said our R is going to be SJK out of the square root of SJJ times SKK. Like we shall need to find our R matrix, capital R is going to be the same as having 1 in the major diagonal and then R1, 2, R1, 3, R2, 1, R2, 3, and then R3, 1, and then R3, 2. Remember, R1, 1, R2, 2, and R3, 3 are all ones. Now, my just finding this. Then if I want to find R1, 2, if I need to find R1, 2, what do I do? I just need to get the, if I need to get R1, 2, what do I need to get? I just need to get the Sj. S is the same as having S1, 2 out of square root of S1, 1 times the square root of S2, 2. Just like that with ease. It's the same thing as having S12 is 0 divided by anything which is the square root of S11 is 6.7 times the square root of S22 is going to be 2.5, which is the same as having a 0 with ease. And then remember R12 the same as R21. I just also need to find out R13. R13 is the same as having S13 divided by square root of S11 times square root of S33. Then this is the same thing as having S13. S13 is going to be S13 is 2.5. That diagram out of square root of 6.7 times square root of now 5, which is the same as having, what's the answer? Remember, after pressing your calculator, we're going to have something like 0.4319, something like that. And then, like last we shall need to find now R23. R23 is the same as having S23 out of square root of S22 times square root of S33. It's the same thing as having S23. S23 is negative 1.5 divided by what is S22. S22 is square root of S22 is 2.5 times square root of 3, which is 5. And then our answer is going to be something like negative 0.4. Yes, 2, 4. And then lastly, I'll write my matrix. I write my R vector as, I'll write my R vector as 1, 1, and then 1. Then R1, R1, 2, R1, 2 is 0, and therefore 2, 1 is 0. Then I'll write now my R1, 3 is 0.4, 319, and then this is the same as having 0.4319 here again. And then lastly, R23 is negative 0.424, and likewise here negative 0.424. And I'll be able to have getting my R matrix. Members, thank you for watching. I think everything has been simple and easy. Now, what we're going to do is just request you to keep trying out some questions. For any questions, feel free to reach out in my comment section. I'll be able to answer. And members, I think you recall my number. I have, it is 0700981468. Just feel free to WhatsApp me. I'll be able to come to your rescue for any questions about this and even other things. Members, thank you for watching. Soccer Annual is your tutor, and I think members, for now, let us stop here. I wish you a nice day, and also try to understand these things because they are easy to understand. Thank you for watching. I am Soccer Annual, your math tutor.